Alright, so this video is on the uses of derivatives. Alright, derivatives are not completely useless. You can use a derivative for to find extrema, however you want to say it. It's points on a graph where a function reaches a high or a low point. If it's a low point, it's a minimum, abbreviated min, or a minima. Or if it's a high point, it's a maximum, abbreviated max, or a maxima. Okay, a minima, maxima, minimum, maximum, min, or max. You'll hear it referred to all three ways. All right. Now, there's something called the extreme value theorem, abbreviated EVT. It says if f of x is continuous on an interval a to b, then both maximums and minimums are on that interval. Meaning, here we have a function. This is a linear function. It is continuous from the beginning to the end. So we could say this is A, this is B. It's continuous over the entire interval. So it's going to have a min and a max on that interval. Same thing here. Here we have a curve. This would be the starting point A. This would be your ending point B. Since the function is continuous, we have a max right here and a min right there. So as long as your function is continuous, you're going to have a max and a minimum. All right. Now, that max and minimum, they're called critical values. Okay. It says critical number is an x value is called a critical number if f prime of c doesn't exist or f prime of c equals 0. Right? So f prime of c is 0 or f prime simply does not exist. Okay? So mins and maxes only happen at critical numbers. All right? Maxes and mins only happen at critical numbers or critical values, whatever you want to use there. Okay, they only happen at critical numbers. So your process for finding extrema is really kind of simple. You take the equation and find the derivative. All right, you know how to do that. Then you take and set f prime of c equal to 0. Actually, that should just be f prime. I don't know why I put a c there. Then you set f prime equal to 0, and f prime does not exist. From this, you will get a list of critical numbers. Now, to test whether it's a max or a min, you're going to try other x values around or near the criticals to see if the critical is a max or a min. What do I mean by that? I'm glad you asked. Let's find all the extrema and label them for y equals x squared. So step 1, we're going to get f prime. All right, so step 1, get f prime. Well, let's take the derivative. We know that this is y prime equals 2x. All right, so we found that. Now, it says get a list of critical values. All right, so we want to take step 2, get a list of critical values or critical numbers. Remember, you do that by taking f prime and setting it equal to 0. So I set f prime equal to 0. So take 2x, because that's f prime, set it equal to 0, and solve for x. So we're going to divide both sides by 2. So x equals 0 over 2, which is simply 0. All right, so for our function here, our only critical number is x equals 0. All right, that's our only critical number. Now, our third and final step, step 3, we need to figure out what is x of 0. X equals 0. Is it a max or a min? All right, is it a max or a min? So what we want to do is we want to try another number close by 0. Okay, so try another number close by 0. All right, so let's try 1 for example. So let's do f of 1. Well, if you go back up to our original function, it's y equals x squared, so it's going to be 1 squared, which equals 1. All right, so if we plug in 0, we get out 0. So that's going to be our critical point, 0 comma 0. Okay, but if we plug in x equals 1, we get y equals 1. So that's going to be a little higher. Imagine this was a graph. That should be 1, 1. Since this point, when we put in a 1, so we put in a number close to 0, since that point is higher than what we got for x equals 0, that means that our critical point x equals 0 is a minimum. Okay, tells us it's a minimum because if we put when we put in 1, we got a point higher on the graph. Because if you drew in some axes, that critical point would actually be our origin. This would be x equals 1. This would be y equals 1. So when we plug in a number close, we physically get a number higher than what we got for our critical value. Since we get a number that's higher, we know our critical number is a minimum and not a maximum. All right. Now for this one, I want to make this the U try. So pause the video for a moment and find the extrema for y equals 2x squared plus 3x minus 1. All right, let's solve this here. So step 1, we want to get f prime, or in this case y prime, because they're the same thing. Step 1, get y prime. So we know y prime equals, that's going to be 4x plus 3. Step 2, we're going to get our criticals. All right, but we get our criticals by setting y prime equal to 0. So set y prime equal to 0. So we're going to take 4x plus 3 equals 0. Subtract 3. Subtract 3. 4x equals negative 3. Divide both sides by the 4 to get it on the other side. So our critical point is x equals negative 3/4. All right. So now what we're going to do is we're going to analyze the critical to try to figure out if it's going to be well, to basically get our y value at that point, because we have our x value. Now we want to get our y value. So now we're going to analyze the critical. All right, so basically we're going to plug x equals negative 3/4 back into our equation. So y equals 2 times negative 3/4 squared plus 3 times 3/4 minus 1. So we are going to get 18. Y equals 18 over 16 minus, because this is a negative 3/4, minus 9 over 4 minus 1, which is going to give us 18 over 16 minus 36 over 16 minus 16 over 16, which is going to give us a negative 34 over 16. So, which means our y is approximately, okay, so y is approximately 2. It's a little higher than 2. It's 2 point something. Okay, it's a little higher than 2. All right, so now what we want to do to find out if it is a maximum or a minimum is we want to try something close to x equals negative 3/4. All right, try something close to x equals negative 3/4. All right, let's try x equals negative 1. That's close. Okay, so go ahead and plug it into our original equation. Y equals 2 times negative 1 squared plus 3 times negative 1 minus 1. So that equals 2, because negative 1 squared is 1 times 2 is 2. 3 times negative 1 is negative 3 minus 1. And that gives us negative 2. All right. That gives us negative 2. So, since when we plugged in our point negative 1, all right, our point is physically higher because this was, no, it should have been negative, because this was y is approximately negative 2 something. I didn't feel like dividing that out. It doesn't really matter, because when we plugged in negative 1, negative 2 is higher on the graph than negative 2 point something. So that means this point is physically lower on the graph than this point. So that means our function has a min at x equals negative 3/4. And we know that. And we know that because f of negative 3/4 is less than f at negative 1. Okay, that is why we know that. Because when we did f of negative 1, we got a larger value. Remember, negative 2, the smaller, when you have negative numbers, the smaller the number, the larger the value. So negative 2 is physically larger than negative 2 point something. So we know at our critical value that we found, we have a min. All right. So that's one of your uses for derivatives, finding your extrema of your function. All right, for this video, there is no ticket in the door. Just make sure that you've done the U-try, you understand how to do all of this material, because tomorrow we are going to work on some problems in class. See you tomorrow.